Today we are going to talk about a new topic called exponential decay. But before we start explaining what exactly is an exponential decay, just to refresh your memory, when we have powers with negative exponents, how we can change it to a positive exponent. Remember from grade 10 that any number a exponent negative number negative b is the same as writing with positive exponent but in the denominator. So a exponent negative b is the same as 1 over a exponent b. For example, 2 exponent negative 2 is the same as 2 exponent 1 over 2 exponent 2, which is 1 over 4. Now, the exponent rules hold for powers which have negative exponent, meaning that when you multiply two powers with negative exponent, you are going to add the exponents. When you divide two powers with negative exponents, you are going to subtract exponents. There are cases that you have fractions as the base of negative exponent. For instance, you may have something like a divided by b exponent negative c. Again, we can write this one as 1 over a divided by b exponent c, but this one is the same as 1 divided by a over b exponent c, but 1e can be written as 1 over 1. If you remember about fractions, to divide two fractions, we are going to flip the second fraction, which is the denominator, and then we multiply. So I can write this one as 1 over 1 times b over a exponent c, which is going to give me b over a exponent c. So I can write a fraction like a over b exponent negative c. That's b over a exponent positive c. And as usual, a and b cannot be 0, and c has to be a natural number. Now going back to our topic of the lesson, which is exponential decay, if you remember previously, any equation of the form a is equal to ab exponent x represent an exponential function. Now when b, which is the base, is greater than 1, then it's an exponential growth. So when b is greater than 1 is an exponential growth. But when b is less than 1, greater than 0, between 0 and 1, this is an exponential decay. The graph of an exponential decay looks like the following. As x increases, the value of y decreases. The point here is when x is equal to 0, which becomes a, which is the y-intercept. So this is your y-intercept here. Now, as before, like exponential growth, the pattern of first and second differences is going to be a repeating pattern, and the ratio is going to be a constant, and this constant is always between 1 and 0. For instance, give you one example is something like y is 500 times, let's say 0.5 exponent x. since 0.5 is between 1 and 0, this is an exponential decay. The initial value or the y-intercept is 500, and the graph looks something like the one which is drawn here. This type of functions are what we call exponential decay. So remember, your base has to be between 1 and 0, which represents a case where the first and second differences, the ratio is a constant less than 1 greater than 0. Our next example is with regard to a radioactive material U-239, which has a decay of about 24 years for its half-life. We are supposed to find the time that it takes for 50 milligrams of this material to decay to 10% of its original amount. Remember, 10% of 50 milligrams is going to be 50 times 10%, which is going to be 5 milligrams. So we have to find the time that it takes to go from 50 milligrams to 5 milligrams. Let's draw a table of values here. Let's have T and A for the amount of material left. T here, it does not represent years. Let's say T represents the number of half-life. This means if I say one half-life is 24 years, two half-life is 48, and so forth. So initially, when there is no half-life, we have 50 milligrams. When one half-life is passed, we know that half of the material is gone. So we will have 25, which is the same as 50 times half. If two half-life is passed, we will have 50 times half, which is the previous one, this one, and only half of it is going to be left, so times half. So it's going to be 50 times 1 over 2 exponent 2. One more time, if it's 3 half-life, we will have 50 times half squared, because previously this is the amount was left, and it's going to be half. So it's going to be 50 times 1 over 2 exponent 3. Now if we look at these numbers on the left and right, you can see when half-life is 3, you have exponent 3. When half-life is 2, exponent is 2. When half-life is 1, exponent of this is 1. And here, this is really half exponent 0, which is this one. So in general, when n half-life is passed, we will have 50 times 1 over 2 exponent n. So our equation becomes A amount left is 50 times 1 over 2 exponent n. N again is the number of half-lives. Now that we have the equation, we can solve it for n. We want to have 10% of original, which we found out to be 5 milligram. So we say 5 is 50 times 1 over 2 exponent n, or dividing by 50, we get 0.1 is equal to half exponent n. As we said in previous lesson, we can solve this one with different methods: trial and error, divide and conquer, graphing, or the log function. I will use the log function here. I'm going to take the log of both sides, so I'm going to have log 0.1 is equal to n log half. Divide by log half, I will get n is equal to log 0.1 divided by log 0.5. Now, if you use your calculator, you will find that n becomes about 3.3. 3.3 half-lives. Every half-life is 24 years, so the time is going to be 3.3 times 24, which is going to give us something like 79.2 years. So this means that U39 takes 79.2 years to go from 50 milligram to about 5 milligram. Our next example is to simplify 3 exponent negative 2. 3 exponent negative 2 is simply 1 over 3 exponent 2, which is going to be 1 over 9. Another example is 6 exponent negative 2 times 6 exponent 3, which is going to be 6 exponent. Since the bases are the same, we are going to add exponents. 3 minus 2 gives you 1, which is equal to 6. Another example is negative 2 exponent negative 4 plus 4 exponent negative 2. Since there is no rules for addition of powers, we should try to somehow change these to the same base. Negative 2 exponent negative 4 can be written as negative 2 exponent 4 plus, and 4 exponent negative 2 can be written as 1 over 4 exponent 2. Now, any number, a negative number exponent, even number, 4 is even here, and negative 2 is negative number, is going to give you a positive number. So negative 2 exponent 4 is going to give you 16, and 4 exponent 2 gives you also 16. Since the denominator does the same, I'm going to add the numerator, so it's going to be 1 plus 1 is 2 over 16, which is 1 over 8. The next example is 4 exponent negative 2 exponent negative 3 divided by 4 exponent 3. When you have power to power, you multiply the exponents. So you will have 4 exponent negative 2 times negative 3 divided by 4 exponent 3. Negative 2 times negative 3 gives you 6 divided by 4 exponent 3. Dividing powers with the same base, you have to subtract the exponents, so you get 4 exponent 6 minus 3, which is going to be 4 exponent 3, and this one gives you 64. Our next example is going to be something like x exponent negative 2 times x exponent negative 3 times x exponent 4. Since the bases are the same, we add exponents, so it's going to be negative 2 plus negative 3 plus 4. Now 4 minus 3 is 1, 1 minus 2 is minus 1, so it becomes x exponent negative 1. If the question asks to express everything in positive exponent, this is x exponent 1, which is 1 over x. The next one, which we should express in positive exponents, is a exponent 2 b exponent negative 3 divided by a exponent negative 1 b exponent 2. Now, to do this one, we have a exponent 2 divided by a exponent negative 1, so we have to subtract, then we get a exponent 2 minus 1, we subtract the exponent, times b exponent negative 3 minus 2. This is going to give us a exponent 2 minus minus is positive, so 2 plus 1 is 3, times b exponent negative 3 minus 2 is negative 5. Since we have to express in positive exponent, I'm going to write this one as a exponent 3 divided by b exponent 5. The next example is 2u exponent 3 v exponent negative 2 exponent negative 3. We are going to distribute negative 3 inside the bracket, so we get 2 exponent negative 3 u exponent 3 exponent negative 3 v exponent negative 2 exponent negative 3. Again, negative 3 goes for each term. 2 exponent negative 3 is going to give me 1 over 2 exponent 3 to make it positive. U exponent 3 exponent negative 3, you multiply exponent, you get u exponent negative 9. V exponent negative 2 exponent negative 3, you multiply exponents, we get v exponent 6. So, to express this one as positive exponents, we write v exponent 6 divided by 2 exponent 3 is 8, and u exponent negative 9 becomes u exponent 9. The next example is simplify 1 over 3 exponent negative 1. Again, a over b exponent negative c becomes b over a exponent c, so this becomes 3 exponent positive 1. The next one is negative 27 over 8 exponent negative 2. Now, 27 can be written as 3 exponent 3, so I can write this one as negative 3 exponent 3 divided 8 can be written as 2 exponent 3 exponent negative 2. Now this is the same as saying negative 3 over 2 exponent 3 exponent negative 2. Now we can multiply exponents. I get negative 3 over 2 exponent, negative 3 times negative 2 gives me negative 6. A over b exponent negative c is b over a exponent c, so this can be written as 2 over negative 3 exponent 6, which we can leave it like this, or you can simplify and see what exactly is 2 exponent 6 or negative 3 exponent 6.